To determine the trigonometric Pythagorean identities, we need to look at a right triangle within the unit circle. So here we have our right triangle, and we have angle theta. And in evaluating the cosine of theta, we know that the cosine of theta equals the adjacent side over the hypotenuse, which is x over the hypotenuse 1. X over 1 simplifies to x. Therefore, the cosine of theta equals x. Let's write that in our triangle. Cosine of theta underneath x. Next, we have the sine of theta equals the opposite side over the hypotenuse. So theta equals the opposite side y over the hypotenuse 1, which simplifies to y. So the sine of theta equals y. Let's also write that in our diagram. Y equals the sine of theta. Now we know by the Pythagorean theorem that x squared plus y squared equals 1 squared. If we look at our triangle in the circle, the base x squared plus the height y squared equals the hypotenuse 1 squared. And since x equals the cosine of theta and y equals the sine of theta, we can substitute those into our equation such that the cosine squared theta plus the sine squared theta equals 1. Now I'd like to point out that when a function is written as cosine squared theta with the 2 in the middle between the s and the theta, that's the same thing as cosine of theta squared. Those are equivalent statements, but we always write it in this format, cosine squared theta. So we've now seen the first and the most important of the three trigonometric Pythagorean identities. The cosine squared theta plus sine squared theta equals 1. If you know this identity, you can easily determine the other two identities, which we'll do now. So again, cosine squared theta plus sine squared theta equals 1. To derive the second identity, all we have to do is to divide each term by cosine squared theta. So in the numerator, here, cosine squared theta plus sine squared theta equals 1. If we divide each term by cosine squared theta, you'll see that that simplifies to cosine squared theta over cosine squared theta equals 1. Sine squared theta over cosine squared theta equals tangent squared theta. And 1 over cosine squared theta equals secant squared theta. We can do the same thing again, only this time dividing by sine squared theta. So again, starting with our primary Pythagorean trigonometric function, cosine squared theta plus sine squared theta equals 1, we're going to divide each term by sine squared theta. Cosine squared theta over sine squared theta equals cotangent squared theta. Sine squared theta over sine squared theta equals 1. And 1 over sine squared theta equals cosecant squared theta. So again, if you know the first and main trigonometric Pythagorean identity, you can easily derive the other two. So I strongly recommend that you memorize the first formula and know how to derive the other two. Now we're going to learn to apply the trigonometric identity. First, we're told that cosine of theta equals 0.8. And we're told to find the sine of theta and the tangent of theta using trig identities. So let's start with what we know. We know that the main trigonometric Pythagorean identity is cosine squared theta plus sine squared theta equals 1. And we were told in the problem that the cosine of theta equals 0.8. So if we substitute in 0.8 for cosine of theta, then we have 0.8 squared plus sine squared theta equals 1. We can rewrite that as sine squared theta equals 1 minus 0.8 squared. Finally, sine squared theta equals 0.36 by subtracting 0.8 squared from 1. And taking the square root of both sides, we get the sine of theta equals 0.6. So we now know the cosine of theta and the sine of theta. And we're also told in the problem to find the tangent of theta. Using our trigonometric identities, we know that the tangent of theta is equal to the sine of theta over the cosine of theta. Since we know that the sine of theta equals 0.6 and the cosine of theta equals 0.8, we can substitute those in and solve to get 0.75. Now graphically, we could look at this on a right triangle, looking at angle theta, and we know, knowing that the cosine of theta equals 0.8, technically it's 0.8 with a denominator of 1, so we can say that the cosine of theta equals the adjacent side, 0.8, over the hypotenuse, 1. Similarly, we know that the sine of theta equals 0.6 over a denominator of 1, so we can say that the sine of theta equals the opposite side, 0.6, over the hypotenuse, 1. And finally, that the tangent of theta equals 0.6 over 0.8. So looking at angle theta, our opposite side, 0.6 over 0.8.